want to break this down into like decompose it into smaller rational or fractions that would add to be that final answer. Okay, so what we want to do to start is to see if this can be factored. Okay, so the first thing we want to do is say, well, let's see, x, and then can the denominator be factored? Okay, so x, and then 6 can either be 2 and 3 or 6 and 1. Since it's all plus, I'm thinking it's going to be 2 and 3, plus and plus. Okay, that equals 5x in the middle, it equals 6 when you multiply. Okay, so this can be broken down. So this is case 1. Case 1 is the denominator, there's that pesky long word again, has non-repeated linear factors. Okay, so case 1, the denominator is what we're looking at. It has non-repeated, so x plus 2 is different than x plus 3, and they are linear factors, x, x, okay? That's why I had to break down the problem first to see if it was factorable. All right, so here is what we do. We factor the denominator, and next we're going to break this up into 2 fractions. The first fraction is going to have the denominator x plus 2, and the second fraction is going to have the denominator x plus 3, because that's really what we're going for. How do we break it back apart into its separate fractions? So the thing is, we don't actually know what goes here and here, so we're just going to call that A and B. I like to use a capital A and a capital B. It really distinguishes and it keeps it really easy to solve, like to see the answers then. Okay, so let's just find a nice color here. Oh, that's nice. Okay, so taking a look at this problem, what we can do to start to solve it is multiply by the denominator. Okay, multiply by the LCM, the least common multiple, which means that we need to have every piece of the denominator in our in what we're multiplying. So we need an x plus 2 and we need an x plus 3. That will also take care of this x plus 2 denominator and this x plus 3 denominator. Okay, so what happens when we multiply this by x over x plus 2 times x plus 3? Okay, we're going to get x times this blue stuff over this exact same thing, right? So this side of the equation is only going to be x. On this side, we're going to multiply a times this blue stuff over x plus 2. So we're going to have a, but the x plus 2's will divide out, and then we'll still have x plus 3. Okay, and then finally, this next term, b over x plus 3 multiplied by this blue stuff, the x plus 3's will divide out. We'll still have a b and an x plus 2. Okay, sometimes people call this like clearing the fractions, because if you multiply by all the denominators, you won't have fractions anymore. It's kind of great because it is a simple way to get rid of all those pesky fractions. Okay, now we have this equation, x equals a times x plus 3 plus b times x plus 2. And there's actually 2 really good ways for us to solve this. And so we're going to do we'll do one of them now this way, and then I'll show you the other way in other example problems, and you can kind of decide which way you like better, okay? So first what we're going to do though is for this method, which is going to be creating a system, we're going to simplify, okay? So on this side we have x, on this side we have ax plus 3a and then we have bx, and then plus 2b. Okay, now just keep that x over there by itself. This we're going to have, let's collect the x terms together. I did this because I don't actually want the a terms together. I want the x terms together. So that would be, there's an x, and that's a plus b. See what I did there? I did ax plus bx. They have a GCF of x. Okay, and then over here, I have plus 3a plus 2b. Okay? All right, now this is the part that took me a while to get, so try to, really focus here. So think about this side of the equation as it needs to match this side of the equation. Okay? So in other words, this side of the equation is an x and no other numbers. Agreed? So, in other words, we could call it x plus 0. Okay, no other numbers. So on this side, this is x, right, times this stuff, plus, and this is the number portion of it. Okay, so in other words, here we have 1x, and here we have a plus b times x. So our first equation is going to be a plus b is equal to 1. Okay, that's the part that it took a little while for me to figure out. So try to look at it here. I'm going to actually change the color of this 0 part. Okay. Okay, so the orange parts go together, all of them. Okay, so x is times 1. But on the right side of the equation, x is times a plus b. Therefore, a plus b has to equal the 1. Okay? It's the coefficient of x. So I'll even write that. Oh, I really want to write it in the right color. I'm going to write it in orange. Coefficient of x. Okay? The other part of the equation, which I'm going to do in this purple, is called the constant, right? So on this side, there is no constant, so it's plus 0. On this side, the constant is plus 3a plus 2b. So these purple things have to be equal to each other. So that's 3a plus 2b must be equal to 0. And that's the constant terms. Okay? I think it's kind of fancy, kind of cool way of thinking about things. Now, what we have and what we're always going to have is a simple little system, right? A plus b equals 1, 3a plus 2b equals 0 that we solve using substitution or elimination, okay? So, for example, if we wanted to use elimination, you might want to multiply this first equation by -2. That way we'll get rid of the b's, okay? So -2a minus 2b equals -2. And then that's 3a plus 2b is equal to 0. Add those together. You get a is equal to -2. Okay. And then so this is elimination. Okay, now I'm going to substitute into that first equation. A is -2 plus b equals 1. So b, add the 2 to both sides, is equal to 3. Okay, so this was a substitution back to solve for the other variable. So the systems will always be pretty easy to solve. They're easy, small coefficients, that kind of thing. Well, look, we found what A and what B are. So if we go back up just a teensy bit, we can see that our answer, how we break this fraction apart, is now clear. So it's equal to -2 over x plus 2 plus B is 3 over x plus 3. Very fancy. Okay, so this fraction is equal to this sum of fractions.